Good morning. Welcome to Civil Engineering Concept. So today we are going to see problem in prestressed concrete beam subject in the topic of deflection of beam. So this is the given problem. In concrete beam with a cross-sectional area of 32 into 10 power cube mm square and radius of gyration 72 mm is prestressed by a parabolic cable carrying on effective stress of 1000 Newton per mm square. The span of the beam is 8 meter. The cable composed of 6 wires of 7 mm dia has an eccentricity of 50 mm at the center and 0 at the support. Neglect all losses. Find the deflection of the beam as following conditions. So first condition is self weight plus pre-stress. Second condition is self weight plus pre-stress plus live load. So these are the given data. So area of the beam is 32 into 10 power cube mm square. Radius of gyration is 72 meter. Initial stress is 1000 Newton per mm square and span is 8 meter. The tendon is pre-stressed in the form of parabolic. So in the problem, 6 wires are pre-stressed. In the problem, they given 6 wires are pre-stressed. Each wire's diameter is 7 mm. The eccentricity of tendon is 50 mm at the support and end 0. So in this problem, they asked to find out deflections for two conditions. So first condition is self weight plus pre-stress. So second condition is self weight plus pre-stress plus live load. So in the first we have to calculate the deflection due to self weight. So deflection due to self weight formula is A is equal to 5W L power 4 384 EI. In the place of W, we have to substitute the self weight value. In the sum, we didn't have any value for self weight, but we can calculate the self weight by multiplying area of the beam into density of the concrete. So by multiplying area and density, we can easily calculate the self weight. So self weight is equal to 0.768 Newton per mm. So in the problem, Young's modulus is not given. So we can take Young's modulus as 38 into 10 power 3 Newton per mm square. So the beam is rectangular sections. The moment of inertia is easily calculated by using this formula BD cube divided by 12. But in the problem, we didn't have any value for breadth and depth. Instead of that, we have value for area. So by multiplying area and radius of gyration square, we can easily calculate the moment of inertia value. By using all these value, we can calculate deflection due to self weight. So next we have to calculate deflection due to pre-stressing. As mentioned in question, the tendon is pre-stressed in the form of parabolic. So the formula for parabolic tendon is A is equal to minus 5 PEL square divided by 48 EA. So P is a pre-stressing force. So in problem we didn't have any pre-stressing force value. Instead of that we have initial stress. By multiplying this initial stress into area of wires. So we have 6 number of wires. Each wire is 7 mm diameter. So from this we can calculate the pre-stressing force. By substituting the pre-stressing force, we can easily calculate the deflection due to pre-stress. So at last we have to find out deflection due to live load. The same formula which we already used to calculate deflection due to self weight, that formula is also used here. Only difference is in the place of W, we have to substitute the live load value which was given in the problem. So live load value is 2 kilonewton per meter, which was already given in the problem. So by substituting all these value, we can easily calculate the deflection due to live load. So in the question, they asked you to find out deflections for two cases. So first case is self weight plus pre-stressing. Second case is self weight plus pre-stressing plus live load. So in first case, deflection due to self weight value is 6.49 mm. Deflection due to pre-stress is minus 12.21 mm. So the net deflection is 5.72 minus 5.72. So the deflections will occur in downward directions. So second condition is deflection due to self weight plus pre-stress plus live load. So the value for deflection due to self weight is 6.49 mm. The value for deflection due to pre-stress is minus 12.21. The value for deflection due to live load is 16.92. So the total deflection is plus 11.2 mm. So the deflections for this condition will occur in upward directions. Thank you for watching.